Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. So in this chapter or video, we are going to look into the subtopic of parametric. We call the topic of 9 differentiation and 9.5 with parametric differentiation, meaning that in this case we're going to look into the parametric equation and how are we going to differentiate or derive what we call the function of parametric. Okay, what's the meaning of parametric here? Solve the first and second parametric derivatives. Okay, then so parametric equations are the equations where x and y are both given as a function of a third variable t. Okay, so for example, okay, let's call as a parameter. So first example, then we have x equal to t squared and y equal to t minus 1. So in this case, there's unknown of x and y. Parametric equation given x and y both given as a function of a third variable t. Okay, now if x equal to function of f with a variable of t and y equal to g with a variable of t, then by using the chain rule, you can determine the dy dx. So dy dx equal to dy with respect to the, recall differentiate y with respect to the t multiplied with dt dx. So where dt dx equal to 1 over dx dt. Or we can also define it as a dy dx equal to dy dt dy dx dt. And second order derivative, second derivative of y with respect to the x equal to differentiate, we call derivative of dy dx. Okay, the function that we derived the first time and we derive again with respect to the x. So in this case, we derive the function of dy dx with respect to the t multiplied with dt dx. And this also, we call this also one of the definition for second derivative of y with respect to the x when x and y will given a, we call the third parameter of t then. Okay, now let's take a look at the first example here. Find dy dx and second derivative of y with respect to the x in the term of parameter t if x equal to 2t cubed, y equal to 4t squared plus 1. So hence find the value of dy dx and second derivative of y with respect to the x if t equal to 1. Okay, now let's solve this question together. Okay, given that x equal to 2t cubed and y equal to 4t squared plus 1. So then dx dt equal to 3 times 2 equal to 6t squared and y equal to 8t and derive or differentiate 1 equal to 0. So using the chain rule, okay, chain rule, so then dy dx equal to dy dt and dt dx. So this is dy dt, okay, sorry for my mistake then. Okay, so dy dx equal to dy dt multiplied with dt dx. Okay, so before that, dt dx, by looking at this one here, we got dx dt. So for this is how we call 1 over dx dt. Okay, or we can also define it as 1 over 6t squared. So dy dx dy dt equal to 8t and dt dx is also considered as a 1 over dx dt here. Okay, we need dt dx, but what we have here right now is dx dt. So dt dx equal to 1 over dx dt, which is also defined as 1 over 6d squared. Okay, so then here right now, 8 with 6 divided by 2, so then 4 and 3 t divided by t squared, so then 4 over 3t. Okay, that is the first solution here. And now, to find the second derivative of y respect to the x, second derivative of y respect to the x. Okay, now we separate this. This we derive the dy dx. Okay, we derive the function of dy dx respect to the t. Okay, and actually that for this second derivative, we implement or we using this again. We cycle the formula of this, but the difference here now is we derive, we differentiate the y respect to the x, and now actually for this one here we differentiate dy dx. Okay, just now it's a y here, and this y now become dy dx respect to the t multiplied with dt dx. Okay, so derive dy dx. What about this one here now? Okay, so I'm going to use a different colors of ink to separate to show that the solution of this. Okay, so okay, so we are going to derive this of dy dx, where differentiate of dy dx respect to t. Actually, we are derive this. Okay, deriving this one here, 4 divided by 3t. Okay, now just imagine. Okay, just treat this as a u and this one as a v. Okay, u prime v minus u v prime divided by v squared. So derive this 4 and differentiate 4 equal to 0 multiplied with 3 minus 4 and differentiate 3t equal to 3 and divide by u prime v minus u v prime divided by v squared, and v here which is 3d squared. Okay, negative 4 times 3 equal to negative 12 divided by 3 squared equal to 9d squared, and then negative between 12 and 9 we can divide by 3, so 12 divided by 3 equal to 4, 9 divided by 3 equal to 3d squared. Okay, so this is the result of derivative differentiate of dy dx respect to the t for this one here now. Okay. In that case, we are going to substitute this here, which is negative 4 divided by 3d squared multiplied with dt dx. And again, dt dx is, recall we're going to use this result of dt dx 1 over 6d squared here again. So multiply with 1 over 6d squared. Okay, so then negative 4 divided by 2 equal to negative 2, and here become 3. So negative 2 times 1 equal to negative 2 divided by 3 times 3 equal to 9 t squared with t squared t to the power of 4. Okay. So what's the question? The next question is now. Okay, find the dy dx and second derivative of y with respect to the x if t equal to 1. Okay, now we are going to what we call copy out the question again. Dy dx equal to 4 over 3t squared. Okay, dy dx equal to 4 divided by 3t, and second derivative negative 2 divided by 9 t to the power of 4. Second derivative of y with respect to the x equal to negative 2 divided by 9 t to the power of 4. Negative 2 divided by 9 t to the power of 4. So if t equal to 1, now dy dx, where t equal to 1, then equal to 4 divided by 3 times 1. And it is equal to 4 divided by 3. And second derivative of y with respect to the x, where t equal to 1. So you can hear negative 2 divided by 9, 1 to the power of 4, and is equal to negative 2 divided by 9. There you go. Okay. Then next, okay, given x equal to ln 4t cubed and y equal to e power of 3t, so find dy dx and second derivative in term of y of t. Okay, it's given here, so we like to find the first derivative and second derivative in the term of t. So dx dt, differentiate the ln. First, it gives you 1 over 4t cubed. Then multiply with derivative of 4t cubed respect to t, then 3 times 4 equal to 12t squared. Okay, so 12 divided by 4 equal to 3, then here t squared divided by t cubed, then it is now equal to 3 divided by t. Okay, 3 divided by t. And then dy dt equal to, okay, so for this one here, y prime equal to f prime x multiplied with e to the power of fx. Do you still remember this? Good. Okay, now this is the one that we're going to implement here now. So derivative of 3t will give you 3, then e to the power of 3t. Okay, so the question wants us to find out the dy dx. dy dx equal to dy dt multiplied with dt dx. So we compare what we have here right now is dx dt, and what we have here right now is dt dx. So for dt dx means that we are going to come out with not in here. So dt dx equal to 1 over dx dt. Okay, so dy dt equal to 3e to the power of 3t, and dt dx is 1 over dx dt. So dx dt equal to 3 over t, then this come out with 1 over 3 over t, or t over 3. So 3 divided by 3, then we get t e to the power of 3t. Okay, then next, we like to find out the second derivative of y with respect to the x. So in this case, we are going to derive or find the derivative of, okay, and then multiply with dt dx. Okay, look at this one again. dy dx equal to derivative of y respect to the t multiply with dt dx. Now, second derivative means that we differentiate. Just now we differentiate the y. It's time now for it's time for us now to differentiate the dy dx respect to the t multiply with dt dx. So for dt dx, actually we are recycle the using again the result of dt dx, which is dx dt is 3 over t and dt dx is 1 over dx dt, or t over 3. Okay, so look at this one here now, and now we are going to differentiate dy dx. Let's say okay, so differentiate, okay, now this one here. Okay, differentiate dy dx respect to the t, meaning that we're going to differentiate this here, t e to the power of 3t. Okay, so now we divide this with t as a u and e to the power of 3t as a v. Then can you guess what are we going to do next? Yes, using chain rule, u prime v plus u v prime. Okay, multiplication between two functions. We define this as a u and this one as a v. So then u prime v plus u v prime, we differentiate this first. Differentiate the u or t here equal to 1 multiplied with e to the power of 3t plus with, okay, t, and then differentiate e power of 3t. So differentiate 3t here, it become 3 e to the power of 3t. So 1 multiplied with e power of 3t, which is e to the power of 3t, plus with 3 and t, 3t, then e to the power of 3t. Or we can also factorize this when you have e power of 3t and e here. So e to the power of 3t multiplied with 1 plus 3t. Okay, so the result of this is e to the power of 3t, 1 plus 3t, and dt dx, dx dt, we got here, so dt dx equal to t divided by 3. Okay, so can you guess what will be the next thing here? So there's nothing that we can cancel, divide or cancel between these 3, and any term is a numerator here. So what can we do here now? We just define this as a 1 over 3 e power of 3t times 1 times t. Then we got t times this times 1 t e to the power of 3t plus e power of 3t times 3 times t times t. So 3t squared e to the power of 3t. Okay. Next example. So now, given that x equal to, as you see here now, and y equal to t divided by 1 minus t, so show that dy dx equal to this one here now. And then find the value of dy dx at the point of 2 and negative 2. Okay. Okay, so now it's given that here x equal to 2 divided by 1 minus t in bracket square. To simplify this, this in fraction, form of fraction. So we bring the denominator above here and become to the power of negative 2. And y equal to t divided by 1 minus t. So we simplify until get here now. So this is the one that we're going to use. Okay, you may stick with this one. X equal to 2 divided by this one here. Meaning that we define this as a u and this is as our v. So dx dt equal to u prime dot v minus u dot v prime divided by v squared. And we are also going to use this here. Okay, you can use this formula for both for x and y. It might be takes a time because both in a fraction form here. Okay, it's okay if you like to use this for here for dx dt and dy dt. It's all up to you. Then I didn't say that it's incorrect, but you may test by yourself. But right now, let's just use we call this one here now. So dx dt equal to, so 2 and negative 2 multiplied with 2 here, 1 minus t, and negative 2 minus 1 equal to negative 3. Derivative or differentiate 1 minus t, then multiplied with 1. So 2 times negative 2 equal to negative 4 divided by, and this come out with, become 1 minus t to the power of 3, or negative 4. 1 minus t, negative 3. Either one, both are actually equal actually then. Okay. And then dy dt equal to derivative of negative 1, differentiate negative 1 equal to 0. And then differentiate negative 1 here, multiply with 1 minus t, negative 1 minus 1 equal to negative 2, and differentiate 1 minus t equal to 1 here. So negative 1 divided by 1 minus t squared, or negative 1. Actually, this is 1 here. Okay. Now, dy dx equal to dy dt, which is negative 1 divided by 1 minus t squared, multiplied with dt dx. Okay, dy dx equal to dy dt and dt dx. Now what we have here right now is dx dt. So dt dx equal to 1 over dx dt now become 1 over this one here. It is now become 1 minus t cube divided by negative 4. Okay. Negative divided by negative, positive 1 minus t cube divided by 1 minus t squared. So 3 divided by 2, so 1 left here. The rest of this we call eliminate on this one here. So 1 over 4 multiplied with 1 minus t. Okay, let's double check with the answers. We call the question then. There you go. Okay, 1 over 4 multiplied with 1 minus t. That's it. Now let's move to the next question then. So find the value of dy dx at the point of x equal to 2 and y equal to negative 2. So then, the question is just now find the value of dy dx at the point of 2, negative 2. So then, dy dx equal to 1 over 4, 1 minus t. Okay. So, x equal to 2 divided by 1 minus t squared. And y equal to t divided by 1 minus t. Okay, x equal to this one here and y equal this. So now, given the question then, at the point of x equal to, at the point, okay, at the point of 2 and negative 2, meaning where x equal to 2 divided by 1 minus t squared. Okay, so then we call cross multiply, then it come out with 2. Okay, so cross multiply and equal 2 here, 2 equal to, when 2 multiplied with this 2, 1 minus t squared equal to 2. Expansion of this come out with 1 minus 2t minus t squared. Okay, so expansion of this 1 minus t multiplied with 1 minus t come out with 1 and minus 2t minus plus with t squared, negative t multiplied with negative t. I think that you still remember this. How we're going to treat this kind of what we call a situation here. 1 minus t squared, which is 1 minus t and 1 minus t. 1 times 1 equal to 1. 1 times negative t, another negative t, negative 2t, negative t multiplied with negative t plus t squared. There you go again. And in fact that we call expand this. 2 minus 4t plus 2t squared equal to 2. So bring these two to the side, become negative 2. Okay, get 0 here. So 2 minus 2 equal to 0. So now 2t squared minus 4t equal to 0. Factorize a t and 2 here, so then we come out with t minus 2. Then t equal to 0 and t equal to 2. Okay, now let's take a look at this one here now. When y equal to negative 2, negative 2 equal to t divided by 1 minus t. Cross multiplication in here, negative 2 times 1 equal to negative 2, and negative 2 times negative 3, negative t plus 2t minus t equal to 0. So 2t minus t equal to t, then negative 2 bring to the side become 2 here. Okay, looks we have a comment here where t equal to 2 and t equal to 2. So we come up with a conclusion that at the point of x equal to 2 and y equal to negative 2, then t equal to 2. So then dy dx equal to, okay, dy dx equal to, now we substitute t equal to 2 here. Okay, so 1 over 4, 1 minus 2, 1 minus 2 equal to negative 1 times negative 4, 1 over 4, negative 1 over 4. Okay, then next, find, okay, just now is a question of B. So for C, find second derivative of y in respect to the x. Okay, when y equal to negative 2. Okay, so now second derivative of y. Okay, we rewrite, recall the solution of, for example, dy dx just now. Dy dx equal to 1 over 4, 1 minus t, and also dx dt, dx dt, this one here now, dx dt, which is negative 4 divided by 1 minus t power of negative 3. Okay, or this one here now. Okay, dx dt equal to 4 divided by 1 minus t cube. Okay, so then second derivative of y in respect to the x equal to, we differentiate the y, okay, or in this case is dy dx, differentiate dy dx respect to the t, okay, multiply with dt dx. So dx dt equal to 4 divided by 1 minus t in bracket of cube here. So then dt dx equal to 1 minus t cube divided by 4. Okay, so dt dx, dt dx. So we are going to find out this first. This is our dy dx. So we are going to differentiate dy dx respect to the t. So now differentiate of dy dx respect to the t equal to, okay, it's a constant 1 over 4 here, 1 over 4, and differentiate 1 minus t, differentiate 1 negative t here equal to negative 1, which is negative 1 over 4. Okay, so then the differentiate dy dx respect to the t equal to negative 1 over 4, and dt dx, dt dx equal to, we call the opposite of this, which is 1 minus t cube divided by 4. So then now it becomes negative 1 minus t cube divided by 16. Okay, so the question was to find out the second derivative of y respect to the x when y equal to negative 2. When y equal to, we have proved just now, when y equal to negative 2, so then t equal to 2. You still remember this? When y equal to negative 2, substitute here, then we get t equal to 2. Then, substitute the value of t equal to 2 into, recall the equation here now. Okay, so second derivative of y in respect to the x when t equal to 2. So this one here now, substitute with negative 1 over 16, 1 minus 2 cube. So 1 minus 2 equal to negative 1, negative 1 cube equal to negative 1 over 16, negative 1 cube equal to negative 1, so negative times negative equal to 1 over 16. Okay. Next question. Now is recall the equation of x with a variable of theta. Just now it's a variable of t, the parameter of t. Now it's parameter of theta here. So find dy dx if it's given x and also y. Okay. Now, differentiate x respect to theta. Derivative of x respect to theta here. So 2 is a constant. To differentiate theta equal to 1 plus differentiate sine equal to cos theta. Okay. And y equal to 2 multiplied with 1 minus cos theta, so then dy d theta equal to 2, okay, differentiate 1 equal to 0, negative, differentiate cos equal to, okay, derivative of sine theta equal to cos theta, and derivative of cos theta equal to negative sine theta. So negative and differentiate cos give you negative sine theta. So negative times negative become positive, equal to 2 sine theta. Okay. Now we got dx dt and dy dt. Then we can find out dy dx. Dy dx equal to dy d theta multiplied with d theta dx. Okay. So means that here, okay, so if I rewrite this all again, okay, dy dx equal to dy d theta, then multiply with d theta dx. Okay, dy d theta is all here, but d theta dx. So we need to define from this dx d theta, so d theta dx equal to 1 over dx d theta, which is equal to 1 over 2 1 plus cos theta. Okay, so dy d theta equal to 2 sine theta, and d theta dx here 1 divided by 2 1 plus cos theta. Then 2 divided by 2 equal to 1. It is now equal to sine theta. Sine theta multiplied with 1 divided by 1 plus cos theta. Okay. Next question. Given that x equal to sine cube 2 theta and y equal to cos cube 2 theta, show that dy dx equal to negative cotangent 2 theta. Okay, so class, derivative of what we call, for example, sine n x respect to the x. Okay, so in this case, I do hope that all of you still remember that the a power of this trigonometric function of n is the first thing that we need to consider. Okay, and then this will be the second, and x is the third part, or the third, what we call things that we need to differentiate. So we differentiate the index first, the power of n, and then the trigonometric function, here sine, and then x, the last one here. So in this question here now, so dx dt here, differentiate the power of trigo function, the power here 3. So 3 sine squared 2t. Okay, we're complete. Differentiate the power 3 and 3 minus 1 equal to 2. Multiply with derivative or differentiate sine, it could give you cos 2t. Then differentiate the function of 2t here, it comes with 2. So 2 times 3 equal to 6 sine square 2t and cos 2t. Okay, now differentiate dy dt. Okay, so the question given to you here now is y equal to cos cube 2t. So then dy dt equal to differentiate the 3 and cos 2 t. Then next, okay, first we differentiate the power 3 cos square 2t, and differentiate cos, it gives you negative sine 2t, and differentiate 2t equal to 2. Okay, 2 times negative times 3 equal to negative 6 cos square 2t and sine 2t. So now dy dx equal to dy dt, negative 6 cos square 2t sine 2t dx dt. So dt dx equal to 1 over everything here. So 1 divided by 6 sine square 2t and cos 2t. So negative 6 divided by 6. Okay, clear. And then sine divided by 1 of the sine for sine square here. So from sine square 2t now becomes sine 2t. So we call divide by 1 of this here. And cos square 2t divided by cos 2t. So we cancel 1 of this with this one here. So let's see now what we have here right now. Negative cos 2t divided by sine 2t. Cos divided by sine is negative, and negative here. Cos divided by sine is cotangent 2t. There you go. Okay. Oh, now I'm supposed to solve the question here. It's okay, never mind. So that's a conclusion. Well, this is the last final slide. We call for this video, and I do hope that this my explanation helps you to continue with your tutorial exercise and past year questions, and as preparation before your final examination. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day until we meet again. Bye.